Hello guys, very welcome back. In this video we'll be learning about post-drift studies, right? Primarily three: convection current hypothesis, seafloor spreading hypothesis, and plate tectonics theory. Now the first question arises, why were these people not convinced with the continental drift theory? A, because the continental drift theory couldn't explain the mountain formation process very well. Secondly, these people were not very convinced with the idea of the continents getting drifted because of some tidal force, because of pole fleeing force, right? And thirdly, the evidence of the continental drift theory was only land-based. So these people, like Arthur Holmes, said, let's find some evidence inside the sea, right? So convection current hypothesis by Arthur Holmes came up in the year 1927, and he said, by lots of observation or near the mid-oceanic ridges, he said that the mantle, what people think is dull, it's not so dull. The mantle has got convection current, and there is complete cell formation. This is because of the radioactive heating. The radioactive heating causes the convection current to form, and the heat is transformed from deep down below to up.
A way of helping to regulate the planet's temperature. It's a remarkable system. Magma heated by the core rises towards the Earth's surface.
There is an ascending limb of the cell and there is a descending limb of the cell. The ascending limb is the place where the ocean forms, and the descending limb is the place where the mountains form, right? Taking cue from the Arthur, and lots of eco-sounding, sonar observation, coring, and geophysical technique observation was done after the World War II, because the ships carried these instruments in order to find a submarine deep down below, right? So lots of observation was taken during this period post World War II, and in 1960 Harry Hess came up with a superb observation that ocean floor, as thought to be flat and featureless, is not so. It has its own topography. Secondly, there is an active trench region where there is high heat flows, and there is complete chain of underwater mountain, right? Thirdly, the ocean floor gets progressively old away from the mid-oceanic ridge. So Harry Hess observes that near to the mid-oceanic ridge, the ocean floor are not very old, but as we move away from it, the ocean floors are really very old. And the last, he observes that nowhere the ocean is older than 180 million years old, that is Mesozoic, right? Now, based on these observations, Harry has postulated that the structures found on the ocean floors are actually the surface expression of the convection currents. Secondly, he postulated that the ascending limb, the traction drag, and the descending limb, these are the three parts of the cell. The ascending limb would have a puncture, would cause a puncture on the ocean floor, leading to the ocean formation. There would be eruption of basaltic lava. There would be elongated rifts, right? The new crust formation would start here, and there would be ridges, and this will be called the mid-oceanic ridge, right? Secondly, second part of the cell is the traction drag, where he postulates that this is a complete conveyor belt system. If new crust forms, there has to be an crust which is getting destroyed, right? So he tells that in the descending limb there is subduction happening, and this subduction is the zone of destruction, and there is trench formation here, right? Now, if we talk of the evidences of this particular seafloor spreading, the best evidence comes from Vine and Matthews hypothesis, where they tell that, you know, first let's talk about their observation before postulating their theory. Now, Vine and Matthews, they observed a peculiar thing that near mid-oceanic regions, they observed and they gathered the data of the magnetism of the seafloor, and they saw and they observed outstanding results. They saw that the mid-oceanic ridge acts as a mirror of the paleomagnetic records. Now I'll tell you what is paleomagnetic, but first let's see observation first. The magnetic observations are symmetrical to the mid-oceanic ridge. Secondly, the magnetic observations are not continuous, right? So there are strips formation here, right? So before telling what is paleomagnetism, let's study what is geomagnetism. That how is geomagnetism produced? And this is because if you see the core, the outer core is fluid because the pressure applied is less and hence temperature dominates here. But if we see the inner core, the pressure is very high and hence the inner core is solid. Now since the outer core is fluid in nature, lots of forces acts on these fluids. For example, there is lots of radioactive decay, lots of latent heat of solidification because outer core is also getting solidified, so it releases heat. And there is the gravitational force, and finally the earth, since earth is moving, it also applies the Coriolis force on these outer core. Now due to these forces, the fluid are convecting, right? And many a times they are turbulent. So this is known as geodynamo, right? Now if we see the outer core has lots of iron, and iron has got electrons. Now the movement of electron causes the electric current, and electric current is associated with the magnetic field creation, right? Now if we see some planets having magnetic field, the terrestrial planet, among terrestrial planets, Earth has the highest magnetic field, while Mars's magnetic field is almost extinct. And the Jovian planets, they have very high magnetic field, right? So this magnetic field is just above the ionosphere, and this acts as a shield against the harmful UV radiations, against harmful solar flares, right? So also protects the Earth's atmosphere from getting degraded as it happened in Mars, right? Now the thing is what most people think, that geographic north and the magnetic north, they are same, but it is not so. The geographic north and the magnetic north have an angle, a difference of almost 11.5 degrees, right? The thing is, this geographic, that is this magnetic north shifts in direction because of lots of turbulence in the outer core, right? Now this magnetic north currently is shifting at the rate of 30 km per year, and it is shifting from Canada to Siberia, right? So lots of recalibration, lots of updation of the instruments are going on, right? Now this magnetic north also helps, apart from the applications I have told, this helps in navigation, this helps in military applications, this has helped the mankind to navigate via ships using the compass, right? Apart from that, many animals have magnetoreception, for example turtles, where they use it to cross the oceans, right? Now, if we come back to mid-oceanic ridge, lots of magma oozes out, and this magma, since it's very hot, it's in paramagnetic condition, that is, its magnetic property is destroyed. Now, as soon as it comes to ocean in contact with the water, its temperature falls, and the point where the Curie temperature is reached, all the ferromagnetic minerals, all definitely the iron, nickel, cobalt, they align themselves to the present magnetic field, right? So domain structure is formed. So paramagnetic turns to be ferromagnetic, right? By the way, if you want to know what is the Curie temperature of iron, it's roughly 1043 Kelvin. For cobalt is 1394 Kelvin. For Fe2O3 it's 893 Kelvin, right? So this solidified magma acquires the magnetic field of Earth of that time, right? And hence, if we come back to the Wien-Matthews hypothesis, he said that these regions shows the magnetic north pole. If say the red shows the magnetic north pole and the blue or the violet shows the magnetic south pole, so it's on the both side, and hence, you know, what was once magnetic north pole, this shows that it is pushing it, right? So yes, definitely it's a twin-headed tape recorder of Earth's at that time magnetic field, right? And it shows the reversal history of electromagnetic field is registered here, right? And he calculates this to be that seafloor is spreading around at the rate of 1 to 6 centimeter per year, right? A very strong proof given for the seafloor spreading hypothesis, okay? And the last post-drift theory was the plate tectonics theory. Now it was the culmination of all the theories, right? Now if we talk of the postulates of plate tectonics theory, it said that the crust, which is the continental crust and oceanic crust combined, and the upper mantle up till 100 kilometer, right? This is a lithosphere, right? The lithosphere is broken, the lithosphere is discontinuous, it's not, you know, continuous all over the surface. It is disjointed into large segments, it's cold and brittle, right? Now this lithosphere plate floats over the asthenosphere. By the way, the asthenosphere is 150 kilometer thick, right? So we talked up till 100 plus 150, 250 kilometers off top of the Earth's surface, right? And the reason why asthenosphere allows the lithosphere to be float on itself is because the asthenosphere acts plastically because of increased temperature and pressure, right? Next, he postulates that the thickness of the lithosphere is 0 to 10 kilometers at the ridges, and elsewhere it's like 100 to 150 kilometers, right? The plates may contain the continent as well as the oceanic surface. For example, one example of is Pacific plate, which is mostly oceanic, right? There are six major plates and 20 minor plates. Pacific, American, African, Eurasian, Indian, and Antarctic are the major plates were accepted worldwide, right? The plates are continuously in motion with respect to each other. Each plate is capable of independent motion. The speed varies from 1 centimeter per year to 10 to 15 centimeter per year, right? And this speed is really appreciable, right? Virtually all seismic activity, volcanicity, mountain building, tectonic activity are localized at the plate margins, and the interiors of the plates are really devoid of earthquake and the volcanoes, right? It's devoid, but we can't say it's completely absent. Based on the interactions, there are three boundaries, that is constructive boundaries, destructive boundaries, and transform fault boundaries. So summarizing the complete post-drift studies, the convection current hypothesis said that the mantle is not featureless, the mantle is not dull, it has got convection currents, right? Next was the seafloor spreading hypothesis. It said that the seafloor is like a conveyor belt, and its best evidence was proved by the Wien-Matthews hypothesis, right, where it said that the ocean floor is twin-headed tape recorder. And finally, the plate tectonics theory said that the Sial doesn't flow over Sima. Actually, it's the lithosphere which floats over asthenosphere, and the lithosphere is not continuous, it's disjointed, right? And there are 6 major plates and 20 minor plates, right? So that's all. Thank you.